first for this code, I went ahead and imported these libraries. I used a lot of libraries from PyTorch, some from neural networks, this one from the activation functions. So yeah, I wanted to check to see for this part of the code, I just wanted to check to see what type of, if I'm using like, CPU or GPU, and it just prints it. So I'm just, setting it to CUDA if it's available, but if not, then we're just going to use CPU. Alrighty, so then step 2 is basically to load and clean the data. So I have to upload this file called alice.txt. So it loads the entire Alice in the in Wonderland text into a single string. This part here just filters out unwanted characters, so make sure to only keep certain like valid characters like letters, digits, punctuation, stuff like that. Now we're gonna go on to the dictionary part, the character mapping. So here we're creating a sort of list for all like unique characters. That's what char is for. For this one, it's just a dictionary to convert all the characters to indices. And then this one is the opposite of that, so it's the reverse dictionary. And then the vocab size is just the length of the unique characters. And then I went in and printed it out. So now I'm going to begin preparing the training data. I set the sequence length to be 40, and then so the sequence length, which is like our input window that we mentioned in class, and so it just tells us like how much we're sliding the window. So in this case we have 5 steps, so it's going to be sliding by 5 characters. And then the data X and data Y represents the initial like input, and the data Y represents the output. Okay, so now what's interesting is that we're going to go ahead and do a loop, and this is actively sliding a window across the text. So this sequence in, it represents the current sequence, while sequence out represents the next character. So we're only just shifting by 1 in this case. And so essentially what we're doing is we're adding this part into data X and data Y, but for the most part we're just converting both of those lists of integer. Okay, so now we're going into this class. So this class called data loader, it's a custom class that I created, and so essentially I have 3 functions. The first one here just stores the sequences for training. Then this one just returns the length of data X, and then this one essentially converts the input to just one hot encoder tensor, and the target Y is actually left as an index value, so we're not using one hot encoder because you're going to be using something called the cross entropy loss function. This is just me setting up the data loader. We're just setting the size to be 64, and then we're just going to be calling that function that class that we just explained, and then yeah, and then we're actually loading it. So now we're getting to the interesting part. So I went ahead and defined a class called LSTM, and it creates 2 layers of it. And here's the so essentially it creates 2 layers, right? And so we had to pass in input size here, and that input size is the vocab size, and that's the one hot vector. And then we had the hidden units to be 128, and then I added a dropout because I find that my model was overfitting, so I went ahead and added a dropout. So I dropped out between layers of 0.2. And the output layers, this part here, we're just saying, hey, put the output layers map from the hidden size to the vocab size. And then we have, of course, our forward pass function. So we just wanted to return just the logistics for each character and the hidden state. Right here, we're just training our model. So we're just initializing the model, loss function, and the optimizer. So this part, we're actually just doing the standard training loop. So we're just, doing the forward pass, calling the forward pass function, calculating the loss calculations, doing back propagation, then doing an optimization step, and then finally averaging the loss for each epoch. So with this big function, I'm passing a couple of parameters in: the model, the seeds, the length of the generated sequence, and then temperature. So I had to do temperature because again I was overfitting, so I wanted to loosen it up a bit. And so the aim of this generate text is just to generate the desired length of characters that we want when we use the seeds and the temperature scaling. This part right here, the idea of that is to disable the gradient calculations. So we just want it to be faster and not really focusing on memory. Like, yeah. So then with this part here, this is encoding the C text. So then here, so this code essentially, we're running the seeds through the LSTM, so we can just initialize the hidden state, and we're also storing the last right here. We're storing the last character to the start the generating seed that we used. And then we're actually going to be looping by one character at a time. And when we do that, we're using the one hot encode on the basic current character. And we're doing this like one step at a time, like one character at a time. And then right here, this little guy, we're just feeding this input to the model, and then we can get the prediction, the new hidden statement. So the idea is just to get the output logistics, and then we're applying the temperature scaling and then providing the softmax to get the probabilities. And then with this part here, essentially we're indexing to get the next predicted character, converting that into the index character back into the character, and then we're appending it to the array. So the point of it is just to sample from the distribution using this, and we're just converting it back to a character and then appending it to the output, and that's what gets returned. And then we just run it. And so this is what I ended up getting. I ended up using CUDA with this much total characters, with the vocabulary size of this, and then I did 20 epochs, and then it generated the sequence.